All right, this is Pre-Algebra, lesson 10.4, space figures. All right, let me fix this here. Space figure, three-dimensional figures, right? So we're talking about not a square or a circle, but like a cube or a sphere. Let's talk about this. I'm going to show you some things. And this is nothing new for you, I know. What is this guy here? I'm going to draw a little something.
Triangular prism?
Yeah, what makes it a prism? What makes this thing a prism? That was not very well drawn. Two parallel sides. Well, here's the deal. This is what you would say. Okay. The base. What is a base? I agree. Bottom, right? It's what it's sitting on. You agree? That's what the base is. But what if I drew it like this? See, where's the base? Where's the base in this object here? And where's the base in this object here? So you can't always say it's the bottom, because the base isn't always on the bottom. Where's the base on this guy? This one is the bottom, right? I mean, it's that guy right here. This guy is a prism because it has two parallel and congruent bases. That's what makes this a prism, okay? Notice that and that are identical. The top and the bottom are identical, right? And they're parallel with each other. And so therefore, and the sides make up what shapes? What shape is the sides? No, that's the bottom. What's the sides? Rectangles, right? The sides make up rectangles. If you have two identical bases that are parallel with each other and the sides make up rectangles, then that is called a prism. Does that make sense? Now I have a question. Where's the base on this guy? It's the triangles again, right? I mean, just because it's the same object, it's just laid on the side, so you can't always say it's the bottom, because right now the bottom is that thing, and that is not the base. Does that make sense? That is not the base. Something else, you have to know the terms. This, we just called them the sides, these rectangle sides. Those are called lateral faces. Lateral faces. I show you this just so you can understand what we're talking about. You have the base, which is the bottom, right? If it's a prism, you have two of them. Could I turn it over and it would still be the base? Right? The sides are the faces, lateral faces. Remember that, so that when you are, what is looking at you? When you put it up on its base, what's looking at you? The face, right? So the sides are the faces. Does that make sense? Okay. A pyramid, can you tell me without looking? How would you define a pyramid?
A triangle,
It looks a little bit more like a...
It's like a prism that's like...
So here's the deal. Let's go back to this. If I have this, so we know that this is a what again? What's that thing called? That's a prism. Why is it a prism? What are the things that make it a prism?
It's two congruent bases.
Two congruent bases. What about a pyramid? There is no parallel base, right? I mean, look, let's just say I take that exact same object, except this time I'm going to erase that guy. I'm going to cut that guy out. I'm not going to have a parallel, similar or not similar, congruent base, and I'm going to have my guy here like this, and then now it's going to go up here to a point. Do you see what I'm talking about? A pyramid has a base that is a polygon. Okay, what's a polygon again? Polygon means many sides, right? Poly means many. So it has a base, and then here it's very simple. What is the faces on a prism again? What are the faces on a prism? What are the faces?
Triangles.
On a prism?
Oh, the rectangles.
They're rectangles, right? They're rectangles. in a pyramid, let me do a little four-sided guy right here. What are the faces now?
Triangles.
Triangles. The faces of a pyramid form triangles. Does that make sense? I don't care how many sides it is. What do they form? Triangles. Do you see what I'm talking about? There's going to be a bunch of triangles as the faces. You all look at a pyramid and recognize that it's a pyramid. You look at a prism, you recognize it's a prism. But it's important that you understand that and you be able to articulate why. Why is this a prism? Oh, prisms have rectangular sides. Pyramids have triangular sides. Does that make sense? Okay. What would be this? This is fun. Oh, let's talk about this really quick. I have this right here. Okay. What is that thing again? What object is this? What is that? What object is this? It's a pyramid, right? Let's get more specific. Do you know what you call the pyramid? You call the pyramid based on its base. So what would you call this? You'd call this a rectangular pyramid because the base is a rectangle. Does that make sense? Okay. What would this be then? Shh, you don't know. You don't know what I'm going to draw. What would that be called then? That's a triangular pyramid because the base is a triangle. What if I have one of those? What would you call this? This is a hexagonal pyramid. Why is it hexagonal? Because the base is a hexagon. Does that make sense? Okay. What about this? What is that thing?
Cone.
That's a cone. What else could you call it? We don't call it. We call it a cone. What else could you call it?
A prism with one base.
It's not a prism with one base. That's what I would say, is that it's a circular pyramid. It looks like it, right? The only reason why you wouldn't call that a circular pyramid is why? What makes something a pyramid again? A triangle side, right? Is that a triangle side? No. If you were to undo this thing and lay it out, it actually looks like this. There's this, and then it goes like this.
What?
That's what it would look like if you were to lay it out and cut it out and cut it open. Right?
Yeah,
You would wrap it around and it would go up high. Does that make sense? So is that a triangle? Almost. It would be if it was like that, but it's curved, and so it's not a triangle. That's why you wouldn't. So then, what else? What about this then? Now, this is true. So what is this guy again? We'll give you one of these. What is that thing? What kind of a prism? A rectangular prism. Why is it a rectangular prism? Because the base is a rectangle. What if I have this? I have a... Oops. What is that guy? That's a 5 of them. What's a... No? Pentagonal prism. This is a pentagonal prism because... Why is it a pentagonal prism? Pentagon is a base, and what are the sides? Rectangles, right? Okay, awesome. Now, let's look at this. Called a cylinder. What else could I call that? And this time I could call it this.
A can.
What else could I call it? A circular prism. Now let's look at this. Now, why would I be allowed to call this a circular prism?
Because it has circles.
Circles has the base. What makes it a prism?
It's congruent bases.
It has no. What is prisms? The sides are.
Wouldn't that be a cylinder? It's two bases.
Listen, hold on. You called it a prism. Fine. Shh. I agree. The base is a circle, right? Agreed? Circle, circle. And they are parallel with each other.
Oh.
And then what does the sides have to be in a prism?
Rectangle.
Rectangles. Is that a rectangle?
No.
Huh. That's weird. Let's look at this.
Oh wait, yeah.
Let's look at this. Let me look at this. What would you call it? You have to say there was a lid here and say there was a lid here. You'd call this a cylinder, wouldn't you?
Yeah.
When I cut it open, what shape does it form?
Rectangle.
A rectangle. Do you see what I'm talking about here? So then technically you could call that thing a circular prism. We don't. There's a very special name for the circular prism. We call it a cylinder, right? Anyway. Oh, and then of course, you know, you have this guy here, and then, you know, he's
Sphere.
right. So a lot of people, what would like a little kid call that? They would call it a ball, right, or an earth, yeah, right. But the technical term is a sphere, right, 3-dimensional. What are the what would it look like if I cut this thing open? I mean, it would be ugly, right? I mean, it would be a mess.
Wouldn't it just be like 2 halves?
It would be a mess. You could do that, right? Yeah, it would be a mess. Okay, so here's the thing about the rest of this, is that what you have to be able to do, this is geometry, right? You're not actually going to take this class until you're a freshman or sophomore in high school. But you do have to be able to, it's all a matter of wrapping your brain around this. There's no numbers to this assignment. It's just a matter of, can you wrap your brain around it? If I gave you this object here, actually, I'm going to draw a little off. Okay. Just a second. Okay. You all know what that object is?
Yep.
What is it?
Rectangular pyramid.
Rectangular pyramid, right? Or a square pyramid. Now, here's the deal. What you have to be able to do is show me the net of this object. The net means that you would cut out, you want it to be in one piece still, but you're going to cut out this object so that it's laid out flat. I'll do this one for you. I'll do this one for you. This is what I'm talking about. It would look like this. And I need you to understand, see that if I was to cut it open, it would look like this, and you need to be able to wrap your brain around it so that you go, okay, is that exactly what that would look like? Because what would you do? You'd take that guy right here and you'd flip it up, right? You'd take each of the sides, flip them up, and then, oh, there's my object. Does that make sense? I have cut it down the sides and laid it out, and there we go. There's our object. Does that make sense? Does that make sense? So I'm going to give you a couple, and I want you to do it. Okay, there's that. On to number 1, and then number 2. And then we'll do number 3, which horrible looking. Okay. All right, here we go. So the first thing we're going to do with this top one is, draw the, okay, so the bottom looks like it's like this. And then, okay, then there's a side here. And there's a side here, and there's a side here, and there's a side here, and then you look at that and you go, wait a second, oh, there's something else I got to get here. What do I have to else do? I mean, like, that's the sides. Now what? You have to have a top. And what would the top look like?
Just another cube.
It would look just like the middle one, right? I mean, that's the bottom, then the top is gonna, Does that make sense?
Yep.
You know what I mean? Sides, and you got to be able to do it in your head. You really have to just wrap your brain around it. Okay, and then number 2, there's lots of ways to do this, but number 2 is a triangle. What is that? Triangular prism. Okay, and so this time it would be. So do you see that there are 3 rectangles, right? And they're all right next to each other, right? And now, can you imagine that I would wrap it around, right? And then there was a top. Now notice this. I would go to the top here like this. And like this. Think about it. So then I would take this thing, you know what I mean? You take this thing here and you fold it up, and then the top flop folds over and the bottom folds up. Does that make sense? But you have to be able to wrap your brain around it. How does yours look? Did you do it?
Yeah.
I just didn't do the triangle shape.
I know.
Wait, except I put the triangles in the middle.
Yeah, my triangle.
Yeah, mine.
Right, okay, so listen, what I could have done is, I could have done it here like that. Right? I could have done it here like this. Right? I mean, think about it. I could have one here and one here. It doesn't really matter in the end, right? The only thing that you couldn't do is you couldn't have them like this, right? You couldn't have them like that because they're on the same side, right? When you fold it over, okay, so as long as there's one on one side and one on the other, you're in good shape.
I put them like.
I know, which makes no sense. Huh? You have to, in your brain, be able to wrap your brain around it. Okay, this last one, the cone. The cone, now you have to, again, imagine that you have that cone right now. Imagine you have it, and you're going to cut it open. Okay, here you would have your circle on the bottom, right? You would have your circle on the bottom. Let me make that a little bit bigger. You have your circle. And then now, so are you imagining it here? So there's your circle, and now okay, I've got this big, long, huge thing that has a point up here, right? And it would go like this, like this. I need to do that better. It would look like this. Now imagine that. Kind of imagine that this piece, right, that piece right here would fold up and you'd wrap it around and you'd have your top up there. Does that make sense? I mean, like, can you envision what I just did? So anyway, the reason why we do mappings like this, not mappings, nets like this, is because of this. Tomorrow's lesson is going to be this. Tomorrow's lesson on our rectangular prism here, right, is that I'm going to want to know the area of the entire surface, the surface area of the object. If I want to know how much wrapping paper is it going to take to wrap this box, does that make sense? I want to know how much wrapping paper it's going to take to wrap this. That means I need to know the area of the top, I need to know the area of the side, of the back, and the front. Does that make sense? I need to know the area of each one. Right? Well, it's difficult to do in a three-dimensional object. It's difficult for me to even look at and wrap my brain around this. And okay, so what you do is you draw a net, and I find the area of this, right? I find the area of this, 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 and then what do I do with them all? Add them all together, and now I have this surface area. You actually will go Does that make sense? And then you're going to find the area of this. How do you find the area of that particular rectangle, Gigi? How do you find the area of that? Base times height, right? Whatever it comes out to, boom, there's the area. Then how do I find the area? Out is important. Since it's a rectangular prism, if this area ends up being 20 square inches, then what's this?
20 square inches.
20 square inches. If this base ends up being 50 square inches, then what's this top? 50. Do you see what I'm saying? And so when you have your triangular prism and you have your three, right? How would I find the surface area? Well, I find the area of that guy, and then I know that that guy's area is going to be the exact same thing as that guy and that guy. Does that make sense? How do you find the area of that triangle, of that rectangle? Length times width, right? Base times height. How do you find the area of a triangle? Half the base times the height, right? And then if that area was 17, then this one's 17. Does that make sense? You draw the net so that you can easily see what you need to figure out to find the surface area of an object. Yes?
Well, okay, if there's like two triangles, could you just do the base times height?
Yes! See, that's somebody who's thinking, right? In that situation, I mean, like, there's two of them, so instead of doing half base times height, then multiply by 2. Anyway. All right. Let me give you your homework. What do we got here? Today is... I have 1 through 16 even. Is that what I want to do? No. We're going to do more than that. We're going to go 1 through 20. No, that's fine. 1 through 16, but we're gonna do all. It's easy. 1 through 16, all. Okay, so what was that page? What did I say? What page is that?